As mentioned in previous resources, Excel can perform highly complex calculations. One such activity is a two-sample comparison of means using t-tests. This example is taken from the NIST Sematech Handbook, in which we want to compare the gas mileage of American-made and Japanese-made automobiles. More specifically, we want to see if there is any significant difference between the average gas mileage. To begin, let's set up our test. Since we actually want to prove that the mileages are significantly different, our null hypothesis will be that the difference is in fact zero. The alternative hypothesis is that the difference of the average mileages is not zero. Because we are not making any assumptions about one being higher than the other, we will use a two-tail test. Also, we need our number of degrees of freedom. We will use the shortcut method, adding the sample sizes and subtracting 2, to find that we have 138 degrees of freedom. But how does Excel help us? We will use the t.test function to find the p-value, which is the probability that the actual difference of the means is greater than that found in our samples. The t.test function requires 4 arguments. The first 2 arguments are the array of values for the 2 samples. Next are the number of tails for our test. Last is the type of data we have. Entering 1 indicates that the values are paired. We enter 2 if the data is homoscedastic, which means that the 2 sample sets have equal variance. A data type 3 is used when the 2 sample sets are heteroscedastic, or have different variances. So to complete a t-test, we really should find the variance for each data set and compare. Luckily, there is a function for that. We will use the function var.s, since we are finding the variance based on a sample of values. First, we will find the variance for American cars. So we have var.s, open a parentheses, A3 colon A81, close parentheses, and enter. This tells us the variance for the American cars is 17.6. Now we find the variance for the Japanese cars. So we have var.s, open parentheses, B3 colon B81, close parentheses, and enter. The variance for the Japanese cars is 37.3. Our data sets are clearly heteroscedastic. Now we can perform our t-test. Equals t.test, open parentheses, A3 colon A81, comma, B3 colon B81, comma, 2, since we have a two-tail test, comma, 3, since our variances were different, close parentheses, and enter. We get an answer that is entered scientific notation. Since 0.35017 is much smaller than the traditional 0.05 we use for comparison of means tests, we reject the null hypothesis. We have plenty of evidence to show that there is in fact a difference in the gas mileage of American and Japanese cars.